All right. I think it's just a half hour. Or I don't think it's an hour-long service.
I don't know. 45 minutes maybe. It's supposed to be the same as that St. Paul and Grafton, and that's usually 45 minutes.
Yeah. So actually then, if I go right after class at 10, I'd probably be sneaking. Show up for communion and bail. It's an hour. It's an hour-long service. Yeah. Okay, so let's talk about exceptions. So, we cooking here? Okay. So since we have our version of string to int that doesn't scream when we pass it Bob, and we have this other version that does scream when we pass it Bob, we would like to mimic the version similar to the integer.parseInt, similar to the way they handle it, where they give you some sort of error saying, hey, this isn't a number, deal with it, as opposed to us, where we are just returning random negative values and stuff like that because it was because of how our method worked. So right before we took a break, we looked at isNumber. And isNumber goes through every element of our string, and if any of them was not a number, it returns false. Right? Okay.
I think we can add a break after return false.
We can do a what?
Add a break.
Well, you mean here?
Mm-hmm.
It's going to be unreachable code. Yeah, I mean, it says it's unreachable. Why? The return statement makes a method immediately end.
Yeah.
Yeah.
You told me. Sorry. I forgot.
A good example. All right. So, okay. Now, one thing this isn't handling yet, we'll come back and look at this in a minute, is negative numbers. Okay, we're going to have to deal with that as well. So, for right now, let's look at how we can do exceptions. So we're going to start off inside of our string to int. Before we ever start doing any of this stuff, we're going to ask a question. We want to know, is the number that was entered, is that guy actually a number? Can he be converted to a number? So here's my string to int. I'm going to ask the question if driver dot is number, and I'll pass it my string s. If this guy is a number, we'll do our normal deal. Go through, convert it, all that stuff. Otherwise, and we'll put an else even though it wasn't really necessary here, we want to create an exception. So we're going to say exception e is equal to new exception. And we're going to say not a number, just for right now. This will just be a good little example. That's our error message that we're going to put out there, not a number. Now, what we need to do is we need to throw this exception. So we're going to say throw e. Okay? Now, in order to throw an exception like this, we need to tell Java that this method has the possibility of throwing an exception. Okay? So we use this keyword called throws, put it at the end of our method, and say, something bad can happen in this method, because we need to have something that we can do in the absence of returning an int. Okay? If they put in the number Bob, we cannot return the integer version of Bob. Right now we are, but it's a meaningless number that only we knew how to calculate it because we knew how our internal stuff worked. It's not going to be meaningful to anybody externally. So we really would rather raise an exception and say, the guy you passed me is not a number. Okay? So rather than returning an int, which by having a return type here, we are telling Java we are returning an integer. Definite. Bank on it. Okay, Java requires us to do it. If I don't do it somewhere in here, it's going to yell at me. So for example, if I take this part out, I hover over this, notice it says this method must return a result of type int. Has to return an int. Well, we look at this and say, well, it does return an int. It only returns an int if I get into this if statement. So it conditionally returns an int right now. Hello. It conditionally returns an int right now, only if I get into this if statement. Okay, so now we put an else, and we have this exception that we're going to throw. And we need to advertise to Java that this guy has the capability of throwing an exception. And if an exception does get thrown, somebody else has to deal with it. All right. Now, what I'm going to do is up here, notice it's yelling at us. It's saying that this guy has the possibility of throwing an exception. I'm going to take the easy way out first. I'm going to pass the buck. So this code right here has the possibility of throwing an exception. I can choose to deal with that. I could try to do this, catch an exception that may occur, and deal with the exception in here. I can choose to do that. Okay? Or I can take the lazy approach and just say, I'm not going to do anything special in dealing with this exception. If a number format exception happens here, it's bad news bears. Okay? We can't do anything about it right now. So if I don't intend to actually deal with it, do anything real here, I would be better off telling main to go ahead and throw that exception and letting whoever is above me deal with it. We're seeing it only at the level of main because that's all we know at this point. We've written all of our programs inside of this one class called driver. In a couple of classes, we're going to be creating our own objects, where we might have a class inside of a class inside of a class calling other classes through method, through method, through method, through method, and some method down here in the bottom might throw an exception, and this guy might pass the buck, this guy might pass the buck, this guy might pass the buck, and then this guy finally deals with it. So you can decide where it's most appropriate for you to deal with that exception. All right? So for us, we're being lazy right here. We're just telling main, by the way, we possibly have an exception here. We're just going to pass the buck to you. You deal with it. And main is the top level method. All programs begin and end with main. So the Java virtual machine will receive that exception. And what it'll do is just spit it out to the screen, just like integer .parseInt does. So now when we call this and we pass it Bob, hello? No, here, not a number. I don't know why that didn't pop up. So we get our not a number exception. And that's the one we wrote. Okay, kind of looks just like the other one. The one that came from, if I comment this out and I run this one, it's weird. So there's the number format exception from the integer class. All right, so now we're kind of mimicking that. So we have two ways of, well, we have a way of throwing an exception. Now, right now, if we put in 123 or negative 123, we're going to get an exception because it's going to say this dude's not a number. But we look at that and we say, well, that is a number, right? For instance, if I call integer.parseInt and I passed it negative 123 and I add 5 to it, I get negative 118. It knows how to turn a negative number into an integer. So how do we deal with it in our code? First of all, how do I determine that something that starts with a negative sign is a number? And then how do we modify our string to int to work for that negative sign? We have multiple tools at work here. We have string to int. So let's think about the path that this takes right now. We have string to int. String to int calls is number. If is number is true, it converts to int. If it's false, we throw an exception. That's our current logic flow. As soon as we come into string to int, the very first thing we do is we check, is the guy that we've been asked to convert to an integer, is that guy a number? So it's calling our isNumber method. We wrote this guy, we wrote this guy. Make sense? And we wrote this logic that does the conversion, and we wrote this throwing exception logic as well. So, the question is, when I call isNumber, how could we make isNumber return true for negative values? Or do I deal with a negative number before I ever call isNumber? How would you detect? Let's say I just asked you to tell me whether or not a number was a negative number or not. So for instance, I throw out the number 1412. Is that a negative number? No. 287. That a negative number? No. Negative 5. That a negative number? How do you know?
By checking the minus sign.
It starts with a minus sign. Negative numbers start with a minus sign, right? Okay, fair enough. You want me to show you another interesting bug in our current code? Is the empty string a number? Yep. According to our program, it is. I don't see any number in here. But we're detecting that it's a number because we've gone through every element in the empty string. And you know what? There wasn't any of them in there that was a non-number. In fact, there wasn't anything of anything in there. So we have a couple of points of weakness right now. We're going to fix those up. All right. So first of all, we're going back to this idea before we fix that little problem. It's easy for us as humans to detect whether it's a positive number or a negative number. Correct? Okay. Well, right off the bat, numbers have to have some number of digits in them. Correct? So right off the bat, where's our, let's see, it's isNumber, char to int, we're using that, string to int. Did everybody write this down who wanted it? All right. Oh, that gold. We just deleted gold. Oh, that gold. All right. If something comes into isNumber, if it has its length is 0, return false. That's not a number, right? So we just made that little modification. Now we'll get an exception up here. Where were we? Oh, I deleted his digit. And we're back. Actually, that'll be, I'm going to go back to that. All right, so I'm back to the problem. I deleted his digit. I'll introduce another method to you. So we have a class in Java called the character class. And the character class has several methods in it. And one of these methods is called isDigit. It takes a char as a parameter, and this guy returns true if C is a number and false otherwise. All right, and that's in the character class. So this guy returns a Boolean, and it is a static method. All right, so this gives us the opportunity to look at class methods versus instance methods a little bit. Up to this point, we have written a bunch of class methods. All the methods we have written are class methods because I've told you we put static in front of them just because. I'm going to stick with that for right now. Okay? I'm telling you that the character class methods also have static in front of them, which makes them a class method. Okay, I'm going to give some meaning to that here in a second. So character class is filled up with class methods. The string class is filled up with instance methods. That is, methods that do not have static in front. Okay, so there's a couple things that we need to write out here before we look at character. Types of methods. Class methods. Actually, let's do a slide for class methods and a slide for instance methods. So class methods. Have the static keyword at the time the method is being defined. So at method definition, the static keyword is present. So we look at this method definition right here, our isNumber that we wrote. Since static is there, that's a class method. Okay? So when we're defining it, we use the word static, and that makes it a class method. Let's see. Class methods are called using the name of the class in which the method was defined. Okay? They're defined using the static keyword. When we then call them, we use the name of the class in which they were defined. And we've already done this. If you look back here, we wrote a class method right here. How do you know that's a class method? Put the static keyword in. We wrote it. This is where we defined it. It's an untapped resource right here. We defined it right here, We put static in front, which makes it a class method. How do we call class methods? Using the name of the class in which the method was defined. So we call it by saying driver dot whatever. That's the name of the class in which our method was defined. Okay, class name here is driver. So we call the method using driver dot. That's what I mean by called using the name of the class in which the method was defined. Similarly, if we have a string s is equal to hello, and I want to call s's length method, which does not have static out front. So whoever wrote the string class, guys at Sun Microsystems, they chose not to put static out front. We'll talk about why you might do one or the other when it kind of makes sense for us to. Right now, we're just going to say they chose. Okay? They chose not to put static out front, which actually makes that an instance method. So here's class methods, have the static keyword, and are called using the name of the class. Instance methods do not have the static keyword at the time the method is being defined, and are called using an instance of the class in which the method was defined. So by example, here's an instance of the string class. I want to call this guy's length method, which is an instance method. That is, it was defined without the static keyword in front. How do we know that? Well, as far as you're concerned right now, it's because I told you. No static here. That's not how it was defined. Okay? So since that was defined without the keyword static in front, that means it's an instance method because the static keyword is not there. How do we call instance methods? We call them using an instance of the class in which they were defined, as opposed to the name of the class in which it was defined. So if I want to call the string's length method, I don't say string.length. I say s.length. Okay? String is the name of the class. This is an instance method. Instance methods are not called with the name of the class. Instead, they're called with an instance. So s.length or bob.length, something like that. I call it with something that is a string. Okay? So that's the difference between class methods and instance methods from a definition perspective and a calling perspective. So now if I showed you a method definition, and we can even look at that real quick. If I take you to the Java documentation, go to java.sun.com, and I'll show you the string class. So once you go to java.sun.com, it's going to redirect you to an Oracle site. Go to Java SE over here on the right. Then go to Java APIs under Java Resources. And then under Java Standard Edition, that's what the SE stands for. You can click on any of the newer ones, 7 or 8. I'll just click on 8. Most of the stuff we deal with will not have changed. So here it gives you a whole list of all the classes that live in Java, a lot of them. Now, by definition, all the stuff that's given to us by default is something called java.lang in that package. So at the top of every Java program, there's an invisible line, java.lang.star. This line is invisibly there on top of every Java program. It's always available to us so we don't have to write it. Okay, that's the core Java language, lives in java.lang. Anything outside of that, we're going to have to start importing other things. And we'll see some of those as we go, but right now we're sticking with just the core language that's available to us by default. We don't have to do anything crazy. So I'm going to go ahead and just click on java.lang because that's going to shorten this list up a lot. This is the stuff that's built into the Java language. And one of these things is a class called string. So here's the string class. I'm going to scroll down to, here's a field summary, we'll learn what those are. Here's the constructors, we'll learn what those are. But here's the methods. For instance, here's a method we all recognize, the char_at method. Char_at method, its name is char_at, it takes in an integer as a parameter, and it returns a char. This guy returns the char value at the specified index. We've seen that method before, right? Notice it does not have static out here. Okay? So I'm showing you the documentation for the string class. Now, I'll come over here, I'm going to show you the documentation for the character class. Character class, let's go down to its methods. Here's its method summary. And I've introduced a method called isDigit. Right here. So isDigit takes a char as a parameter. This determines if the specified character is a digit. It returns a Boolean, and what's right here? Static. So just by looking at this line in the documentation, we know exactly how to call that. It's a class method. Why? Because it's defined with the keyword static. How do we call class methods? Using the name of the class in which the method was defined. What's the name of this class? Its name is the character class. Similarly, here's the string class. Here's the char_at method. Method's right here, called char_at, takes an int as a parameter. This is what it does. This is what it returns. No static. Class method or instance method? It's an instance method. Why? No static when we defined it. How do we call instance methods? Using an instance of the class in which the method was defined, as opposed to the class name. So for this guy, to call him, we need an instance of the class in which this method was defined. What class was this defined in? It was defined inside of a class called string. So I need to create an instance of the string class and then use that instance to call that method. Make sense? Okay. You're going to find for the remainder of this course, every single time I show you a method, I'm going to ask you, is this a class method or an instance method? And I'm going to ask you, how do you know? Or if you answer wrong, I'm going to say, tell me why he's wrong. Okay, it's always guys that are wrong. And something I'm going to be drilling is this idea of when you see a method being defined, how do you know if it's a class method versus an instance method? Versus if you see a method being used, how do you know it's a class method versus an instance method? And what I mean by that is, right here I'm using a method, right? Is that a class method or instance method? Instance method. How do you know? Class name's not defined. I think you might know what you're talking about, but you're not saying it right. The way I'm calling it, I'm not calling it with a class name. I'm calling it with an instance. Okay? So right here, I'm looking at a method being used. So something we want to make sure we don't get confused with is when we're seeing a method being used, we are not looking for whether or not the word static is there. Static is only involved when we're looking at the method definition. Okay? When we actually see a method being used in the wild, the only way we can tell a class method away from an instance method, assuming it's not a syntax error, is by how it's being called. If it's being called by a class name, it's a class method. If it's being called by a name of an instance, it's an instance method. Now, naming conventions typically dictate that class names start with a capital letter. It's not a rule, it just happens to be a naming convention. So if you've noticed here in the documentation, string class, capital S. Character class, capital C. If you look at these class names over here, I realize the text might be a little short, but we can see they're all capital letters. A little small, but they're all capital letters. Okay? Nothing will keep us from writing classes of our own with all lowercase. There's not a rule. But typically class names start with an uppercase letter. Typically instances start with a lowercase letter. Variable names typically start with lowercase letters. Okay? So we're saying we suspect that S is likely an instance as opposed to a name of a class in this case. But there's nothing illegal about me doing that. Now you look at this and you say, okay, well, one of two things is possible, assuming it's not a syntax error. We either have a class that somebody's created called S, which is possible because we can create our own classes. It's not a very descriptive class, so that would probably be poor programming practices, but not illegal. Or somebody's used unconventional variable names. In this case, we used a variable name that started with an uppercase letter. In fact, it was only an uppercase letter. Nobody's getting shot, but it does go against naming conventions. So in this particular case, we would be speculating whether or not this is an instance or a class method by just looking at how it's being used. We would know just from experience that, oh, this guy's a string. I know about the string's length method. Therefore, this guy must be an instance. That makes sense? But if I show you some random code that's using some method of some class you've never heard of, and I ask you to speculate as to whether this is an instance method or a class method, the only thing you have to go off of is what comes before the dot here, and is it start with an uppercase letter or not? Really, is it a class name or is it a variable name? Make sense? All right. Now, I did have a couple of you ask me questions. For instance, I've advertised that class methods, for instance, string to int, is this a class method or instance method? How do you know? Yeah, the way I'm calling it is with driver dot. If I show you it down here, is this a class method or instance method? Class method, how do you know? Static. Here I'm looking at the definition. Static, okay? Now, class method has static. How do we call class methods? We call them using the name of the class in which the method was defined. What's the name of this class? Driver. So we say driver dot string to int. Okay, and let me go ahead and turn that into something real. So I'll go ahead and run this, and we see we get, oh, we still have that is digit problem. Let me just fix that real quick. Just convert that to the characters is digit. So somebody already wrote that for us. It's in the character class. I just showed it to you over here. I showed it to you here. We have a character class that has a method called isDigit. Pass it a char, returns true if it's a number, false if it's not. It's a class method written in the character class, so we call it by saying character dot isDigit. And it solves the exact same problem our old one did. So I just replaced driver.isDigit with character.isDigit.
I mean, what if your class is
What who?
this class, driver is named driver?
That would give you an error in that particular case. I thought you were asking the other question that people are going to be asking. So let me show you this. So now that we see this isn't broken, let's go ahead and run our code and see if this works. So we get our 8. Okay? So we converted the string 3 into the number 3, added 5 to it. Proves that's an 8. Well, I've told you since string to int, since it's a class method, that is, it's defined with the keyword static out front, we must call it using the name of the class in which the method was defined. So we say driver dot, whatever. We see that this still works without saying driver dot. Okay. Now, it deals with context. This kind of falls into the same category for me as whether or not you use opening and closing curly braces when it comes to for loops. Things like that, what we talked about last time. Okay? It's never wrong to put the curly braces in there for for loops and if statements. Even if you only have one statement following the if and one statement following the for, it's never incorrect to surround it by curly braces. I think it makes the code look more structured. I think there's a lot of advantages to it. Okay? Interestingly enough, a newer language that Apple released 8 months ago or something and keeps evolving is a language called Swift. And their Swift programming language is kind of a revamping Objective-C, which is a relatively old programming language. And most of the decisions they make in Swift deal with having to write less stuff. Okay, so for instance, when you define a variable in Swift, if you want to define a variable of type int, you just say something like var a equals 5. And at that exact point in time, it notices that you put an int inside of this variable. That guy's now an int. Why did I have to type int to tell you it's an int? Okay? So the punchline I'm saying is that all the decisions they seem to have made in the Swift programming language goes towards this idea that don't make the programmer do stuff that isn't necessary. Funny caveat to that is if statements and loops in Swift require curly braces. Not optional in that language. They require it. So Apple has agreed with me. At the programming level, language level, Apple says it's no longer optional to put curly braces or not put curly braces on your loops and if statements. Okay? So I'm telling you a brand new language, a language that's newer than Java, newer than C#, newer than Objective-C, that has the main goal of reducing how much you have to type, has said you have to type the curly braces. That's pretty good evidence, I guess. So always type the curly braces. Now, we deal with context. Let me kind of do this on a separate slide. So we have context. We could be calling. So context is how do you define context without using the word context? Context is the type of environment in which we are making a variable or method call. Okay? We have two types of contexts. We have a static context and we have a non-static context. Static contexts occur within a method defined as a class method using the static keyword. Okay? So if we are inside of a method that was defined with the static keyword, it is true to say that we are inside of a static context. Main, right here, was defined using the static keyword. Therefore, this environment in here is a static environment, which means anywhere in here, anything that we do, it will be assumed that we throw the name of the class that this method is defined in front of any of our calls. So this driver dot is optional in this case because this method right here is being called from within a static context, and that static context lives within the driver class. So everything that we call from within a static context will have driver dot assumed to be in front. Everything that we call from within an instance context, which we don't know about yet, will be assumed to have something called this dot in front, which we'll learn about in the coming classes. Now, having said that, back to my statement about it's never wrong. It is never wrong to go ahead and call a method using the name of the class in which it was defined, even if it isn't required because of the context you're currently working in. Okay? Contexts aren't that hard to grasp, I guess, after you've seen it, but the less things that we have to remember, the less things that we have to worry about not screwing up, the better. It's never wrong. Plus, if I'm teaching you this nice strategy about how to call class methods versus instance methods, I don't know why I put context. Here, let's put context after that, but before contact. There we go. So I've taught you this nice strategy of class versus instance, where these guys are literally opposites to each other, right? Class has the static keyword and called using the name of the class. Instance does not have the static keyword, and you call it using an instance of the class, as opposed to the name of the class. If you follow this structure, this little protocol for this, you never have to worry about getting it wrong until you start writing code where you omit stuff because you're allowed to. Make sense? So I would recommend never leaving off driver dot. Similarly, when we start working on our writing our own objects. So as an example, let's see, go to 300 maybe. So here's a class that we created. Notice that I'm saying this dot. I say this dot. I say this dot. I should have said this dot. Okay? Here, I hadn't put this dot, but this guy is an instance context because there's no static in front. Therefore, it's assumed that anything inside of here is being called from an instance context. But I usually argue always put this dot in there. So this is my way of explicitly saying I'm talking about this payload right here. And we'll talk about the this keyword a lot. Don't worry about it. But I'm just really comparing class methods versus instance methods right now. Okay, it's never wrong, even though it's not required in any of these situations here. Here it is. Here it's required because we have to differentiate between this version of payload and this version of payload. So it actually is required on this one line right here. But all the other occurrences of this here are not. Okay, so my recommendation is always call the methods using the fully qualified method name. Class name for class methods, instance for an instance method. All right. So that's that. Here's our character. I showed you the character is digit, which solves the same problem we wrote before, but now it's built into the language. So we have another tool for our toolbox. We have this character class that has a couple of things in there for us. Is digit is one of them. We have a couple other ones. We have is uppercase, is lowercase, two uppercase, two lowercase, all in the character class. Also all class methods. Let's see, what were we in the middle of doing before? Oh, is number. So for is number, right now, we made it so this guy, well, we need to finish remaking it this way. We need to ask the question if s.length is equal to 0. So if s's length is 0, then that means this guy is not a number. Otherwise, let's just keep cooking and do what we did before. Okay? So that's what is number is going to do for us here.
What about the negative?
Okay? Yeah, what about the negative? So now we come back to string to int. Again, we're back to this little diagram. String to int first says, is this a number? Okay? If it's a number, then we need to do our convert stuff. So we have a choice. We can determine if this guy is a negative value before we call his number or after we call his number. We might say that the negative thing only makes sense for numbers, right? Maybe it only makes sense for numbers. So we're going to go ahead and do it inside of is number. So is number should return true if we pass it something that is a positive or a negative number. Okay? So what we can do here, inside of is number, we're already handling the case where if its length is 0, return false. Now, as we walk from the end or from the beginning towards the end, right now we know that there's at least one character in it because we got past this guy right here. Now, would the string that be a number? No, that's not a number. That's a dash. That's a minus sign. Okay, but we are going to allow for there to be a minus sign at the beginning of the number. we're going to say that's legal. Okay? So, how do I test for that and then check the rest of the string?
str at 0, because the first one on the left. Right?
Okay, so I can ask a question. Else if, well, here, let's just do it as an if right now. We'll decide if we want to have it as an else in a few minutes. So if s.char at 0, that's the very first character, which we know exists now, right? We know that we at least have one character. If that guy is what? Okay, so we could say if that guy is equal to this, return false? Yeah, we're not dead yet. We would have an and?
Yeah.
Okay, what do you want to say here?
And as the length is 1.
No, we don't have the number yet. This guy's determining if something is a number.
Keep checking the other number.
Let me ask you this. What if I started checking my number from position 1? I'm not even going to look at position 0 yet. I'll start checking my number from position 1 all the way to the end. If I find anything in there that's not a digit, I'm going to return false. It doesn't matter if there was a plus or a minus at the beginning, right? Well, not a plus. It doesn't matter if there was a minus at the beginning. If there's something that's non-numeric in the middle of it, it's done. Okay? But now, outside of here, before I just return true, I want to check to see if the character at bucket 0. At this point, if I'm out here, I know that everything but bucket 0 is numeric. I know that to be true if I'm still kicking right there. So I need to check bucket 0. Bucket 0 is legit if it's either a number or a minus sign. So what I'm going to do is I'm going to return s.char at 0 equal to the minus sign, or s.char at 0, pass that to character dot is digit. So this is a Boolean expression. This is a Boolean expression. This whole thing's a Boolean expression because it's done in terms of the logical ORs. Okay? So this says return, well, what's a Boolean expression? Any expression that boils down to a single value of true or false. So at the end of the day, all that stuff I have highlighted there will either be true or it'll be false, which is the kind of value that this guy is supposed to return. So this is going to boil down to true if at least one of the sides of this OR is true. So if this guy either started with the minus sign, we'll return true, because that means it's just a negative number. Or if the thing at bucket 0 is a number, which means it didn't start with the minus sign, but we were dealing with a digit. Make sense? If either of those is true, this whole thing will boil down to true. If neither of them is true, which means it didn't start with the minus sign, and the first character in it was not a digit, then we're going to say, okay, well, we only checked so well up here. We kind of took for granted what bucket 0 was going to be, so we'll go ahead and return our false now. That make sense? So we're going to check everything but bucket 0 up here. Then we'll do our final check for bucket 0. Keep in mind, for loops are pre-check loops. So what if we did have the string 3? Should that guy be a number? Yeah, that's a number. In here, though, we're not even going to check 3 because we're starting off at bucket 1. The only legal bucket in this string is 0. So I is 1. Is 1 less than 1? It's not. Length of this string is 1. So we'll fall past the end of this for loop, but now we'll ask the question. Is the character at bucket 0 a minus? Nope. Is the character at bucket 0 a digit? Yes. So this will return true, as it should for that guy. Make sense? Okay, so now is number handles negative numbers in terms of checking to see if it's negative, but does our string to int handle negative numbers? If we're here, we know that S is a number. But it might be negative. Correct? We know it's a number, but it might be negative. And we're going to run into some major issues if we give a minus sign. If we give a minus sign, we'll try to convert a minus sign into a number and have some issues. So how can we fix this? I know I have a number, but the number might be negative. Does my code here work for everything that's not a minus sign? Sure. I'm starting at the end of the string. I'm going to the very beginning of the string. If the beginning of the string happens to have a minus sign, I probably only want to go to there. That make sense? So, what we're going to do here, we can do a couple different things here. Is we're going to say if s dot char at 0 is equal to a minus sign. That means this is a negative number. So if I'm looking at a minus sign at bucket 0, I'm dealing with a negative number. So now I have to deal with this appropriately. Okay? So I'm going to create a couple of variables up here. I'm going to have an int multiplier. I'm going to start this off at 1. And I'm going to have an int end. And we're going to start this off at 0. If multiplier, if we're dealing with a negative number, that is s.char at 0 is negative, then what I'm going to do is I'm going to set multiplier equal to negative 1. And I'm going to set end equal to 1. This 0 is always going to go to whatever end is. So if it was a positive number, end will be 0. If it was a negative number, end will be 1. We'll stop 1 short of where we stopped before because we're not going to try to convert that minus sign into something else. Okay, so end tells us where we're stopping. The standard multiplier for positive numbers is multiply by 1. Don't do anything to it. But if it's a negative number, we're going to multiply by negative 1. So at the very end, rather than returning the sum, we're going to return the sum times multiply. Make sense? Okay, so we just did a little trick to make this work. We set up a couple of variables that we could then use later on, and we just made sure those variables were equal to the values we were interested in. Okay, so now this guy should be able to handle negative numbers for us. So those are negative 118. All right. Not too bad. So we're drilling these little problem-solving things. None of them are too difficult, but we see little stupid stuff like that. Like, okay, well, how do I think through that? How do I do that thing?
I think we haven't solved the problem if the string we are putting is a negative sign. Only a negative sign. We haven't solved the problem if it's a big number.
If this
Negative without number.
is number, so it's not going to be length of 0, okay? We only have one character in it, so that's going to fail. No, it solves it. So is bucket 0 a minus? Oh, is bucket 0 a minus sign? Yes, it is. Is the character at bucket 0, this will be true. It'll treat this as a number. So we can say if it starts with a minus sign and its length is greater than 1, or bucket 0 is a digit. I think that'll solve it. Because where it was failing before is if it started with a minus sign but it only had a length of 1, it was treating a minus as a negative number, as a legitimate number. So yeah, so this guy doesn't do anything right now. I'm assuming we get our little exception. The negative 1 should work. So there's our 4. All right.
What about the number starts or ends with space?
Number starts or ends with space. I think we would probably consider that to be an error, but it's a good question because I'll show you a fix for that. So let's say we do that. This is going to say we had a non-digit, because a space is not a number, right? But there is a good string method, and here I'll actually show it to you, then you can tell me how to call it. So it's a method called trim. So here's the trim method right here. This returns a string whose value is the string that was called, that called this, with any leading and trailing white space removed. So it cuts off beginning and ending white space. Trims it. Okay? So tell me, class method or instance method? Instance, how do you know? No static. How do we call instance methods? Using an instance of the class in which the method was defined. So what I would do right here is inside of string to int, the very first thing I would do is I would set s equal to s.trim. So we'll trim it up. So if we do that, then we could just throw stuff in here all we want. Make sense? But understand that trim will not solve that problem. Trim doesn't get rid of that white space. Only the space before and the space after. So it'll still detect this as not a number. There's our error. That make sense? Okay. All right, so that's that. Character class. Let me show you a couple other ways we can do some of that stuff. Some more tools for our toolbox, if you will. So I have a string s, and we'll start this off with hello. And now what I'm going to say is string s2 is equal to s dot substring. And I'm going to show you two versions of substring. First one's going to be this one. So there's a method called substring. That returns a string. It is an instance method, so no static. Takes nothing as a parameter. Actually, I'm sorry. It takes an int as a parameter. I'll name it begin. And when this guy does is he returns a string that is the original string minus the characters between bucket 0 and begin non-inclusive. In other words, it returns everything from begin to the end of that string. So, for our example here, hello, I'm saying substring 2, this is bucket 0, this is bucket 1, this is bucket 2, it'll boil down to LLO. Everything from 2 on to the end of the string. All right, so this will show us LLO. We also have a second version of this guy. String S3 is equal to S dot substring. And this one we're going to pass it 1 and 3. So it's another version of substring. String substring int begin int end. This returns a string that is all of the chars between begin and end, non-inclusive. So that means it'll start with begin and go up to, but not including position end. It'll give you the substring in there. So as an example, 1 to 3, this is 0, this is 1. So to get 1, 2, but not 3. So this will be the string EL. This will be bucket 1, bucket 2, not including bucket 3. Up to, but not including 3. Make sense? So if I print out S3 here, it'll be EL. Okay? Now we're able to take some substrings of stuff. Polymorphism. Scary word. That means more than one method with the same name but a different number and or type of parameter. So, this is an example of polymorphism. We have two methods, both called substring, but they have a different number and or type of parameters. This one takes in a single integer. This one takes in two integers. Okay? But this would not be an example of polymorphism. If I took that and I said, oh, there's another method, and this one takes an int blah. Both of these methods are called substring. They both take a single int. Java does not care that you name this one begin and this one blah. In Java's eyes, these are the same methods. Okay, so this would not be an example of polymorphism. This would be an error. But Java allows us, and so do our other modern languages, they allow us to have more than one method with the same name that takes in a different number and or type of parameters. For instance, the first version of the substring allows us to take the substring from a certain point all the way to the end. The other version of substring allows us to take the substring from a certain point up to but not including another point. Both of them are taking the substring, but they work given a different number of parameters. Make sense? So that's an example of polymorphism. Okay, now, some more tools. More tools. String manipulation. In our homework today, we had something like 123 plus 5 minus 7. Something like that, right? And we thought, you know, let's walk through this one character at a time and go ahead and get those, split it up, do the math, blah, blah, blah. Well, what if we could get at those things more easily? We have something called the Stringtokenizer. Stringtokenizer. The Stringtokenizer splits a string up on tokens. There's actually another way we can do this too, but I haven't introduced arrays yet, so that'll have to wait till probably next class. But for this, let's look at some examples. (123 plus 7 minus 2). Go something like that. I'm going to go ahead and I'm going to create a string tokenizer. St is equal to new string tokenizer. And we're going to build it out of our string as well as the expression. The tokens. So the tokens that we're interested in here are plus, minus, times, divide. Okay? And we want it to tokenize this guy on these tokens. Now for right now, don't worry about this new keyword. We'll talk about that. Now Stringtokenizer does live inside of a different library than java.lang. I'll show you in the documentation here. We have java.util, which is another common one that we'll use. It has a bunch of utility stuff in it, and one of the things in here is called Stringtokenizer. Right here. Okay, and Stringtokenizer has a couple of constructors, which we don't know what constructors are yet, but I'm just telling you this is how we call it. We're using the one right here that takes in a string as well as a list of delimiters as strings. And here are the methods we have available to us. First of all, notice none of them have static in front of it. So they're all instance methods, so we call them all using an instance of the class in which they were defined. That is an instance of the Stringtokenizer class. Okay? So we can have it tell us the number of tokens. We can ask whether or not it has more elements, whether it has more tokens. We can get the next element. We can get the next token. And then we can get the next token based on a single delimiter. So let's look at this as an example. So we went ahead and we built our Stringtokenizer. Notice Eclipse is yelling at us because it's saying the Stringtokenizer lives inside of java.util. So you can hover over this and they'll say, oh, one fix is import java.util. So I clicked on that, and now java.util.stringtokenizer is imported for us up here. You could have also just typed it yourself. Okay. Now, one thing that you'll sometimes see is this. People go up here and import java.util.star. And what that says is import everything from the java.util library. All of it. Realistically, it's probably not a big deal. It's just text documents. Not a huge deal. Now, your program is going to be bloated because now you have all of these libraries you've brought into the executable that you never used. You used one thing from java.util, and that was Stringtokenizer, and you just said, I'm going to make all of it available to me, just in case. Okay, so good programming practice would say only import the specific things that you're going to use. The nice thing is Eclipse does this for you, so you will rarely have to type this in yourself. But understand what Eclipse is doing for you. Eclipse does it the right way by default. It imports just what you're using. Okay? So now it's not red anymore. So we have our Stringtokenizer. So I'm going to say while st dot has more tokens. System.out.println st.nextToken. So a couple questions here for you. First of all, why did I use a while loop here? Has more tokens returns true as long as there are more tokens left inside of the tokenizer. I'm giving you that information. That's what has more tokens does. It's in the documentation as well. Every single time I get a token, st.nextToken, that removes the token from the tokenizer. So every single time I call st.nextToken, the tokenizer will have one less token than it did before. So I'm going to keep printing out tokens and removing them as the side effect over and over again as long as I still have tokens. Why did I choose a while loop for this as opposed to a for loop? It's not a counting problem. For loops lend themselves to counting problems. What kind of problems do while loops lend themselves to? Yeah, where we don't know how many times we're going to have to spin. In this particular case, we know what our string looks like. But what if we had read in something like some giant document that we read off the internet? We have no idea what the contents of it is. And now we run this through the tokenizer, and we're going to split it on commas or something like that. So we're dealing with like CBS data or CSV data, comma-separated values. So we're going to split it up on commas, let's say, and I put it through there. I have no idea how many tokens we're going to have. Could be 5, could be 5,000. So I might run it through here with a while loop and say, I'm just going to keep reading tokens as long as there's more tokens. However long that is. That makes sense? So that's why a while loop makes sense. Now, there is a counterpart to this has more tokens. That is st.countTokens. This tells us how many tokens there are in the the tokenizer. So does that mean that I can say for I equals 0, I is less than st.countTokens, I plus plus, and then print out that? Are these equivalent? You can't do them back to back because next token will remove them. But other than that, are these two things equivalent pieces of code? Well, let's see. I'm going to take this away. We'll just do the while loop first. We'll look at our tokens. We're going to have 123, 7, and 2. Okay? We didn't get the operators. If we wanted the operators, there's another version of the constructor that takes in a parameter where you can say whether or not we want the operators. Now we'll get the operators. Okay? So that's our while loop version. Here's the for loop version. While loop version. For loop version. You want less than or equal to? Yeah. All right. Thought you told me those were equivalent. Tell me why those are different. Deals with the concept of side effect. Everything you need to know for this, I've told you in the last couple of minutes. Of course he waits for the last 20 minutes of class when our brains are already mush. See, he already went to sleep. I think the guys in the back, they already left. My hot dogs got here, so they can watch the recording. Why are these different? The hint is it has to do with st.nextToken. When we call st.nextToken, a token is physically removed. It is removed from the tokenizer. How does a for loop work? We start I off at 0. First time through, number of tokens, as we have true here, is going to be 1, 2, 3, 4, 5. 5 tokens. Is 0 less than 5? Yes. Print out the first token. 0 becomes 1. Is 1 less than 4? Not 5 anymore. Now it's 4. So we removed a token. Is 1 less than 4? Yep. So we'll print out the next token. 1 becomes 2. Is 2 less than 3? Now we have 3 tokens. We could do that. Yeah, so what he wants to do is he wants to say int count is equal to st dot count tokens, and then say I is less than count. And this will give us the same output. Because now you don't have a moving target. Okay? It's an important thing to understand because that can happen sometimes. When you have things like Stringtokenizer that has side effects, you sometimes get moving targets. st.count tokens kept changing. Every single time I printed out a token, I removed a token. So the count's going to be one smaller than it used to be. And my whole Boolean expression, this whole for loop, is operating on this idea of how many tokens there are. And it was a moving target. Okay? It's so side effect is important to consider. So in this particular case, probably the while loop made the most sense. All right. So we have this thing that goes through and gives us our numbers, our operators, all split up. Right? Could we have used the Stringtokenizer to make our process? Where's our process? Oh, did I delete all that already? Good. So we're going to just get rid of all this. Nothing good can come out of that stuff. Okay, so we're going to write static int process expression. And just take a string s as a parameter. We're going to go ahead and create our Stringtokenizer in here to split that up. And we're going to be splitting up s, not expression. Well, here, we'll call it expression. Okay. Now, as we're going through it, we know the very first thing we're going to find is a number because of our rules, right? We knew what those things look like up here. So for right now, I'm going to make this void just so we can continue to explore what's happening up here. So if my string looks like this, 123 plus 7 minus 2, the tokens I'm going to have available to me are the 123, the plus, the 7, the minus, and the 2.
If you put minus 123, will consider as minus or?
That's a good one. That's a good one. Let's use it as a token. Don't start it with a negative number. So, can we use Stringtokenizer to make our life easier for process expression? Let's forget about that starting with a negative number thing for right now. Okay, fair enough? Because really that would have broken in our other one as well. We would have seen the minus as an operator. Yeah, so it doesn't make this any worse than what we had before. Our original process expression would have failed for negative numbers. Didn't support them, only supported positive. So we'll assume we don't have negative numbers. So let's just look at this for positive numbers only. if I'm getting tokens in this order, that's num2. This is my first operator. So what I'm going to do here is I'm going to say while st dot has more tokens, I'm going to create a string num1. Let's set it equal to the empty string. String num2 is equal to the empty string. Char op is equal to the question mark. Okay, and then I'm going to have a string cur token. And we're going to say cur token is equal to st dot next token. So we'll go ahead and read it in. All right. First thing we're interested in is whether or not this guy is a number. Okay, not like what we were dealing with before. What we were dealing with before was whether the first thing we were looking at was a digit. Now we're interested in whether or not it's a number. That make sense? Okay. How do I detect if it's a number? I want to show you something interesting here. I'm going to take these spaces. I'm going to put some spaces in there. We're going to run this again. It ignored the spaces. Did it? Is this a space? Row. Can we fix that? I'll just trim them all. So right there, we ignored spaces, which is the same thing we did before, right? So anything that we pass in, we'll trim. Any tokens, we'll just go ahead and trim. Get the white space off either side. Okay? So we're good. Cur token now ignores white space. So now we know it's either an operator or it's a number. Well, how do we know the difference between an operator and a number?
I mean, operator should be just one. So just check.
Could numbers just be one too?
No, they could be more. So check if it's operator. Otherwise, it's a number.
Yeah, I like that. Check if it's an operator. Now I know that cur token will have at least one character in it. So I can look at bucket 0 of it. So I can say if dot index of cur token dot char at 0. If this guy is not equal to -1, that says if the current guy I'm looking at is a operator, then I'm going to do operator stuff. Otherwise, must be a number. Okay? If it's an operator, we have our same stuff as before. If num1 dot length is equal to 0, then we'll set num2, or num1 rather, equal to num2. Otherwise, do math stuff. Regardless, we're going to set num2 is equal to the empty string, and we'll set cur op equal to cur token dot char at 0, because cur token is a string. He comes out as a string. It'll be the string plus sign. We're storing it as a, actually we just called it op, not cur op. So we'll just extract the character from that string that is one character long. Else, as you said, it must be a number. Okay? So if it's a number, what do we do with numbers? Well, it's been in num2. No, back to our thing here. Is this no? This? Oh, we dump it. That's fine. Doesn't matter. All right. So for walking through, if we see an operator, we either, if it was our first operator we ran into, then we're going to do what? The first operator will just copy num2 over to num1. Otherwise, we'll do our math stuff. We'll fill that in a second. Regardless, we'll zero out num2 for reading in the next guy, and we will get the operator. If it's a number, what do? We set num2 equal to cur token. That's it. That's all we do with num2. Before, we were building up num2. Not now. We have the whole number. It's inside cur token. We'll just set it equal to num2. That way, when we come up here to do our math stuff, we're good to go. So we'll write our little math stuff thing. Static. Will we have it return a string? Yeah, we had it return a string. What do we call it? Math crap. Math crap. This guy takes in a string num1 and a string num2 and a char op if op is equal to the plus sign. Then we'll say return the empty string concatenated with integer.parseInt num1 plus integer.parseInt num2. That's if it's a plus sign. Else if it's a minus sign, do minus. Else if multiplication, do multiplication. Else if division, do division. Else return the unhappy face. That means they sent in an operator that wasn't a legitimate operator. We probably should throw an exception, but we won't because we're running out of time. All right, so we'll just return these unhappy face, bad things. That's what old Mac computers used to do. Let's give you the sad face on the screen as things were crashing. All right, so this is our math crap. We pass it in the two numbers as strings, and we pass it in our char op. So here's our math stuff. So what are we going to do? We're going to say num1 is equal to driver.mathcrap num1, num2, num1, num2, and op. Okay? After this while loop is done, question is, do we have anything extra to do now? The last token we read in will not be an operator. Therefore, we will not get into our math stuff, just like before. So when we exit this while loop, we know that we have a final token called cur token. And that final token needs to be dealt with. Okay? Now, remember, well, let's do it this way. We're going to ask our same question as we had before. If op is equivalent to the question mark, that means we're going to return integer.parseInt num2. I need to change our process expression back down. Now it's going to return an int like before. So it'll return that. Otherwise, we need to do one last little mathy thing. What's the mathy thing? Return integer dot parseInt of that. num1, num2, and up. Huh?
Do they have to change, I mean, the end of the program, do you have to change the operator?
Oh, I see what you're saying. So we're back up here at our ops. So we noticed this guy was an op. So we went ahead and did this. Otherwise, we do our math stuff, passing it to cur op, and then we grab our new op. Here at the very end, we don't have an extra op to grab. Okay, so now we should have a process expression written in terms of Stringtokenizer. So we should be able to say something like system.out.println driver.processExpression exp. Yep. Seems to do it. All right. So not necessarily significantly shorter, but with the tokenizer now we have the ability to grab things as full tokens rather than having to build up strings. Does that make sense? So in hindsight, this was probably easier, but everything's easier the second time around, right? Okay, but we saw another way of doing this. So now we have another tool in our toolbox with this tokenizer that if we're in a situation where we need to split stuff up on a series of tokens, we can. All right? Another cool thing you can use the tokenizer for, that's kind of a fun little caveat, I guess. Let's say that we wanted to let's say I wanted to write a method called remove vals. Remove vals takes a string as a parameter and returns a new string with all the vals removed from it. All right. One thing we can do is we can create a string tokenizer, passing it S, and tokenize it on A-E-I-O-U, A-E-I-O-U, all the vowels. All right. Then what we can do is we can say string answer is equal to the empty string while st dot has more tokens. Now notice I use this version of the tokenizer that does not return the actual val portion. It doesn't, the one we use down here, where was it? Said give me the tokens, give me the separators as well with the true. Up here I'm saying I don't want the separator. So it's the same thing as saying false, like this. Do not give me the separators. Okay? So by doing that, I can just say answer is equal to answer concatenated with st.next token. And then in the end, I can return answer. So now I should be able to do a system.out.println driver.remove vals, and let's just do give it the whole alphabet. And there it is with the vowels removed. Make sense? So kind of a cool Cool trick. All right. Now, homework. Are you tired?
My memory got stuck, so I have to
You boot. Out of memory error? All right, let's see. Good news is this is an easy homework assignment. When I do it next week, it'll look real easy. All right, so first one, let's talk about the report, because the homework's actually related to the report. Write a 3 to 5 page paper discussing the role. Shut up! I'm talking about your homework assignment. You can start babbling in 4 minutes. All right. So write a 3 to 5 page paper discussing the role of binary, octal, decimal, and hexadecimal in computing. So why do we have different standard bases? I mean, we could have all sorts of different bases, but why do we have the ability to do things in binary, octal, decimal, and hexadecimal? Where are they valuable for us? When is it appropriate to use hexadecimal versus octal versus binary versus decimal? Why do we have so many different ways? At the very least, cover the following topics. Why do we need so many different ways to represent data? Efficiency related to working with different number bases. And when and why might we need to use a base greater than 16? Okay, so that'll come into the 16 is hexadecimal. Okay, so one of the things you'll be looking at is when is hexadecimal an appropriate base to use? Why might we need something even larger? Okay? The programming assignment is to write a Java program that has at least the following 2 methods. So you only have to write 2 methods. Okay. You should thoroughly test. You actually probably want to write more than 2 methods. You want to write a lot of helper methods like we did today. Okay. You should thoroughly test your methods on several values. First method, static int, base to decimal, should take a string representation of a number as well as an integer radix. That's the base you want to convert it to. Okay, so base to decimal takes in a string and returns an integer that is that string converted to base 10, assuming that string is currently in base radix. So this method should take in a string representing a number and the base or radix of that number, and should convert that number to its decimal equivalent and return that value as an int. You may assume that the radix is a number between 1 and 36. So I should be able to pass in a string representation of any number between base 1 and base 36, and then you have to return the integer decimal equivalent of that. Okay? Second one is decimal to base. You should take in an integer number as well as an integer radix, the base you want to convert it to. And it should return the string representation of that. So if I pass in the number 17 and radix 2, it should give me as a string the binary version of the decimal number 17. Okay? Now, you can only use the things I've shown you in class. Okay? I promise you next week I will show you the nice pretty shortcut that's built into the language that will just do all this crap for you. But since I haven't shown that to you in class, you cannot use it. Okay? And for those of you who are going to do lots of Google searching, I've shown you the version of integer.parseInt that only converts a decimal number as a string into an int, not the one that works on other bases. So you cannot solve this with integer.parseInt, is what I'm saying. I'll show you how to solve it with that next week. Remember we talked about polymorphism today? There may or may not be a second version of parseInt that might be very helpful for this, but you can't use it. All right? Questions about that? Here's a couple of hints for this. First of all, if you haven't converted numbers before, research that. When we converted decimal to decimal today, right? Okay, you're going to see that as you're going through it, you're going to see that there is a very distinct pattern. Whether you're converting from binary or whether you're converting from base 10 to binary, base 10 to octal, base 10 to hexadecimal, they're all the same. They're all the same. So convert multiple numbers both directions and start looking for those patterns. That way you can write it into generic methods that you can convert any base 10 number to any other base and a number in any other base back to base 10. Okay? So do your due diligence and solve the problem as a person first. Understand the pattern so that when you write it, you'll see these aren't that long. Okay? Questions, comments, concerns, bribes? All right, I will see everybody next week. Well, I'll leave it on the recording just in case. At some point, the undergraduate program has their spring break, and I'm not sure, is it before this class ends or after this class ends? Is it before or after this class is over?
After this class.
It's after? Okay, then no big deal.
It's the
Because I will be in Florida that week.
What can I bribe you with, sir?
Huh?
What can I bribe
I don't know how much money you got on you.